Welcome! Today we're taking a deep dive into the architecture and implementation of a web-based Excel clone built entirely with React, TypeScript, and Tailwind CSS. We'll explore how modern web technologies can be used to create complex, high-performance applications that rival traditional desktop software. At its core, this project is a web-based spreadsheet application. It delivers core Excel functionalities, including support for multiple sheets, a wide range of cell formatting options, data filtering, and the ability to import and export standard spreadsheet file formats like CSV and XLSX. The entire application is built using a modern tech stack: React for the user interface, TypeScript for type safety and scalability, and Tailwind CSS for rapid, utility-first styling. The application structure is modular and component-based, as seen in our main app component. The entire state is managed globally by a spreadsheet provider, which makes the data and actions available to all child components. The UI is divided into three main sections: a toolbar at the top for actions and formatting, the main spreadsheet component, which is the interactive grid, and sheet tabs at the bottom for managing different sheets in the workbook. The application state is built around a few key data structures defined in our store. A cell can hold a value and a cell style object. A sheet is a two-dimensional array of these cells, along with metadata like its name and any active filters. Finally, a workbook contains an array of all sheets and keeps track of which one is currently active. This structured approach is crucial for managing the complexity of a spreadsheet. To manage state changes predictably, we use a reducer function. Every user action, from typing in a cell to applying a style, dispatches an action object. The reducer takes the current state and this action and returns a new, updated state without mutating the original. This pattern ensures that state updates are centralized and easy to debug. We have actions for everything: setting cell values, adding new sheets, applying filters, and handling copy-paste operations. Now let's talk about the most complex part, the spreadsheet component. This file is responsible for rendering the entire grid, including row and column headers, and handling the vast majority of user interactions like mouse clicks, drags for selection, keyboard navigation, and cell editing. It's where the magic happens. A spreadsheet can have millions of cells, and rendering them all at once would crash the browser. To solve this, we use a technique called windowing or virtual rendering. We calculate which rows and columns are currently visible in the user's viewport, plus a small buffer. Then, we only render the DOM nodes for those visible cells. As the user scrolls, we recalculate and render the new set of visible cells. This keeps the application fast and responsive, regardless of the sheet size. The component uses a comprehensive handle key down function to manage all keyboard interactions when the grid is focused. This includes navigation with arrow keys, Enter and Tab, as well as shortcuts like Control-C for copy and Control-B for bold. We also have dedicated mouse handlers for clicking, dragging to select cells, and interacting with row and column headers, including right-click context menus for inserting or deleting rows and columns. The toolbar component provides the user with intuitive controls for common actions. This includes file import and export, text formatting like bold, italic, and underline, and applying colors and borders. Each button, when clicked, simply dispatches the appropriate action to the central store. For instance, clicking the B button dispatches a set cell style action with a payload to toggle the bold property for the current selection. At the bottom of the screen, the Sheet Tabs component allows for workbook management. Users can see all the sheets in the current workbook and switch between them with a click. A plus button lets them add a new sheet instantly. We've also implemented functionality to rename a sheet by double-clicking its tab, which temporarily turns the name into an editable input field. All these actions, of course, dispatch actions like add sheet, set active sheet, and rename sheet. A key feature is interoperability with standard spreadsheet formats handled by our file handler. We use the Excel.js library for this. When exporting, we iterate through our workbook's data structure and map our cell values and styles to the format Excel.js requires, then generate a downloadable XLSX file. For importing, we do the reverse. We parse the uploaded file with Excel.js, then transform its data structure back into our application state format, effectively loading the entire workbook into our clone. Finally, let's briefly look at the project's configuration. It's a standard Vite project with React and TypeScript. The package.json lists our dependencies, which are surprisingly minimal: React, React DOM, and UUD for generating unique sheet IDs. The development dependencies include Vite and TypeScript types. Our vite.config.ts sets up the development server and environment variables, and the index.html serves as the entry point, loading our React app and external libraries like Tailwind CSS and Excel.js from a CDN. In conclusion, this project demonstrates how a powerful and feature-rich spreadsheet application can be built on the web using a modern, component-based architecture with React and a robust state management pattern. By focusing on efficient rendering and a modular design, we can create a highly performant and scalable user experience. Thank you.